Hello. So we are looking at which of these graphs are considered normal. And so I gave you these four and wanted you to kind of brainstorm and think about what normal means to you. Now we're going to actually kind of look and see what that is. So for these graphs, when we're looking at something normal, we really only look at the curve. Okay, graphs can look very rigid and jagged, especially if they're histograms or dot plots. And so what we like to do is we like to make curves that kind of estimate their shape. So for instance, on this first one, curves up and back down and around. Okay. On this one shape, we have a steep up and then it tails down. This one here, we go up, we go down, we go up, and we go down. On this one here, we have a little bit of a hiccup, and then it goes kind of like that. So when we're looking at something that's normal, this usually helps us see if it is. And what we think about when we think of normal graphs are graphs that are kind of uniform or symmetrical. So if we look at these, we can see that this one here is indeed normal. Okay, and we're going to take a closer look at why that's normal. This one has some issues. This one is called skewed to the right. And that's because we have this tail that's much further along than the left side. This one here, we have bimodal or two modes. If you remember, a mode is the number that appears the most. And this one here, we have an outlier. Right here. It doesn't look like it really belongs with the rest of the graph or the data that we're dealing with. And these are some of the things we want to look at when we're looking at graphs or histograms or distributions to see if it is normal. Our normal should look pretty symmetrical on both sides. It should have one peak, and all the data should flow around it. So that's why we would say this one here is normal. This one here we said was skewed right, so it's not normal. This one has two modes, and this one has an outlier. So those are some of the things that we want to look for in terms of what is and what isn't normal. So if we look here, we're going to just draw some graph, a normal distribution curve, and we're going to start looking at what its features are, okay? So for this one here, and excuse my poor drawing, it looks a little normal. We're going to look at some of its key features. So what makes a distribution quote unquote normal? Well, there's a few things. So generally we don't draw all the histogram or the dot plots and stuff under it because this curve is outlining what we're going to see. And we can see right here in the middle at the highest point, this here is the mean. It's the average. It's what's in the middle of all of our data. Not only though is this the mean, it's also our mode because our mode is the point which has the most data. So the highest peak is also going to be that. And it's our median because it's directly in the middle of the data. Between both sides, it's right down the middle of it. So we have in the middle, the mean, the mode, and the median are all the same point. And that is a big characteristic of a normal distribution. Then, as we go to the left or to the right, we start to notice that it has a dip or a curve that starts to get a little bit lower as we go. And that's on purpose because if we think about data, if we think about everybody in the class, let's say we all take a test, and I say the class average is an 82%. Does that necessarily mean everybody got an 82? No, it just means that's the average. Some people get more than average. Some people get less than average. But the further we get away from the median or the mode and the mean or that middle point, that average that I'm talking about, it's less likely to happen. So this little tiny chunk here is less likely. This little bit of the more chunk is less likely as well. Most of our data is going to be right in this middle section. And that's why there's so much room there, that the majority of us are going to be right around average. Some people do a lot better, some people do a lot worse, but for the majority of everything, we're going to be right here in this middle section. And the nice thing about these normal distributions is by looking at it, we can see that it's also symmetrical on both sides. Meaning that when we cut this in half, I pretty much have a mirror image of itself. This whole side here looks identical to this whole side here. So we have that symmetry that's there. The other thing we talked about was that the mean, median, and the mode are all the same. Okay? And so that's what makes a graph normal. So when we see something that looks like this, that's skewed to the right, we can tell that, sure, it does not look symmetrical. My mode is going to be right here, because that's the highest point. But that's not the average. The average is probably somewhere over here because all that data is pulling it there. So that's our mean. And then if we look at the median, the most medium point here is probably going to be somewhere right along here, because that's the right in the middle data there. So you can see this one's not symmetrical. It doesn't have the same mean, median, or mode. So we would say this is not a normal graph. And like I said, the normal graphs look nice and symmetrical. They look like a bell curve or a hill, as you describe it. They don't have those slopes off to the right that are different than the left side. They also don't have two modes. They also don't have that outlier. So you can see why in this original that these are not normal, and the only normal one is up there. And so that's what we're going to be dealing with all throughout Module 9. And today is just getting to know what a normal graph looks like. So now we're going to move on to standard deviation in the next video.